This learning module tackles the topic reducing and enlarging formulas. Pharmacists may have to reduce or enlarge formulas for pharmaceutical preparations in the course of their professional practice or manufacturing activities. Generally, official formulas, as specified in the monographs in pharmacopoeias, such as the United States Pharmacopoeia and National Formulary, are based on the preparation of 1,000 milliliters or 1,000 grams. Other formulas, as those found in the literature, may be based on the preparation of a dosage unit, for example, 5 milliliters or 1 capsule, or another quantity, for example, 100 milliliters. In extemporaneous compounding, a pharmacy may be required to prepare a dosage unit from the monograph of the official article. Industrial formulas may be scaled up to quantities of ingredients sufficient to prepare hundreds of thousands of dosage units in a production batch. In each of these instances, a pharmacist may calculate the quantities of each ingredient required for a smaller or greater quantity by reducing or enlarging the specified formula respectively, while maintaining the correct proportion of one ingredient to the other. At the end of this unit, the student will be able to apply ratio and proportion in performing calculations to reduce or enlarge formulas for pharmaceutical preparations stated in quantities and in proportional parts, and apply interconversion of units in the calculation of quantities given in formulas for reducing and enlarging. As I have stated before, reducing and enlarging formulas are important techniques in order to prepare a dosage unit, such as in reducing or scaling down a formulation, or in scaling up to quantities of ingredients sufficient to prepare hundreds of thousands of dosage units in a production batch in a process called enlarging. Take note that in either of these techniques, there should be a correct proportion of one ingredient to the other. In this particular learning module, we will be discussing the different techniques which can be used in reducing and enlarging formulas. For example, the methods of ratio and proportion, dimensional analysis, and factor method may be used to reduce or enlarge a pharmaceutical formula. For many, the factor method is the simplest to use. The factor is defined as the ratio of the quantity of formula desired to the quantity of formula given. In order to illustrate reducing and enlarging of formulas, we will be solving some problems. Practice problem number 1. The formula for an ophthalmic ointment is as follows. Sulfacetamide, 10% weight in weight, prednisolone acetate, 0.2% weight in weight, phenylmercuric acetate, 1 is to 125,000 weight in weight, mineral oil, 1% weight in weight, white petrolatum, QS add or quantum sufficient add or a sufficient quantity to make 3.5 grams. How much of each ingredient would be needed to manufacture 2,000 such tubes of ointment? Among the multiple ways to determine the amount of each ingredient in this particular formulation, there are two common techniques which are very easy to do. First, we can calculate the amount of each ingredient in one preparation of the ophthalmic ointment using the percentages that are stated in this particular formulation. Remember that when we say 10% weight in weight, it basically means 10 grams of the drug sulfacetamide are contained in 100 grams of the ointment. Because the amount of the ointment is 3.5 grams, we can perform a ratio and proportion to determine the amount of the drug sulfacetamide in one ophthalmic ointment, which weighs 3.5 grams. The amount of the drug is 0.35 gram. Another way by which you can perform this operation is by dimensional analysis, because 10% weight in weight means 10 grams of sulfacetamide are present in 100 grams of the ointment. We will simply multiply the weight of each ointment to determine the amount of sulfacetamide in one formulation. And we get the same answer, 0.35 gram of sulfacetamide. We will do the same to prednisolone acetate. This time, we will just perform dimensional analysis. 0.2% weight in weight means zero point 0.2 gram of prednisolone acetate in every 100 gram of the ointment. The weight of of each ointment is 3.5 grams. That will give us a value that is equal to 0.007 or 7 milligrams of prednisolone acetate. Next, we have here a ratio strength of phenylmercuric acetate. Phenylmercuric acetate is used as an antimicrobial preservative for this particular preparation. Remember that 1 is to 125,000 weight in weight ratio strength basically means that 1 gram of phenylmercuric acetate are present in 125,000 grams of the ointment. Now, let's do ratio and proportion. So the weight of the ointment is 3.5 grams. We can determine the value or the amount of phenylmercuric acetate Y, and that is equal to 3.5 divided by 125,000. It's 2.8 times 10 to the negative 5. Now, the mineral oil is present as 1% weight in weight. So 1% means 1 gram in 100 grams. We'll do dimensional analysis again. So 3.5 grams of the ointment divided by 100 grams of the ointment will give us a value that is equal to 0.035 gram of mineral oil. Now that we already are able to compute the amount of each ingredient in a 3.5 gram ophthalmic ointment, we will simply multiply each of these values, 0.335, 0.35 gram of sulfacetamide, 0.007 gram of prednisolone acetate, 2.8 times 10 to the negative gram of phenylmercuric acetate, and 0.035 gram of mineral oil by the factor, which is 2,000. Because according to the problem, we will need to compute the amount of each ingredient needed to prepare or manufacture 2,000 of such tubes of the ointment. So the factor here is basically your 2,000. So this time, what we are doing is we are enlarging the formula, or we are performing scaling up. So here's what we're going to do. We will simply multiply 0.35 gram by 2,000, and that is equal to 700 grams, 0.007 gram of prednisolone acetate times 2000, this will be equal to 14 grams. 2.8 times 10 to the negative 5 gram times 2000 is equal to 0.056 gram of phenylmercuric acetate, and 0.035 gram of mineral oil times 2000 will be equal to 70 grams. So all of that will be needed to prepare 2000 tubes of 3.5 gram ophthalmic ointment using white petrolatum as a base, or basically as a diluent. So if we were to determine the total weight of the ointment that will be prepared producing 2000 tubes of the ointment, we simply multiply 3.5 by 2000, and that will be equal to 7000 grams. So when we will be interpreting this particular formulation, what you will do to prepare 2000 of such tubes is to mix 700 grams of sulfacetamide, 14 grams of prednisolone acetate, 0.056 gram of phenylmercuric acetate, and 70 grams of mineral oil, and add sufficient quantity of white petrolatum to make 7,000 grams of the ophthalmic ointment. That is just one of the many methods by which we can solve this problem. Now, another way to determine the amount of each ingredient that would be needed to prepare 2,000 of such tubes of ophthalmic ointment is to multiply the total amount of the ophthalmic ointment by 2000, which is, once again, our factor. And once again, this will be equal to 7,000 grams. And then we will simply determine the amount of each of these ingredients given as percent strength or ratio strength using the total amount that is 7,000 grams. This time, we will just perform dimensional analysis. So, for sulfacetamide, 10 grams of the drug sulfacetamide are contained in each 100 gram of the ointment. Multiply it by the total amount of the ointment that will be prepared, which is 7,000. That will be equal to 700 grams. For prednisolone acetate, which is present as 0.2% weight in weight, it means that we have zero point 0.2 gram in every 100 gram of the ointment times 7,000 grams. And that will be equal to 14 grams. Now for the ratio strength, 1 is to 125,000 weight in weight basically means 1 gram of phenylmercuric acetate are present in 125,000 grams of the ointment times 7,000 grams. And that will be equal to 0.056 gram. And lastly, for mineral oil, 1% weight in weight means 1 gram per 100 grams of the ointment times 7,000 grams. And that will be equal to 70 grams of mineral oil. So basically, what we get are the same amounts of each ingredient. Now, in certain problems, you may be given the number of parts of each of the ingredient instead of the actual percent or ratio strength that they are present in the formulation. In that case, it becomes crucial for you to determine the total number of parts equivalent to the amount of the product that you would like to prepare. So in this case, since we are given 5 parts of calcium carbonate, 1 part of magnesium oxide, 4 parts of sodium bicarbonate, and 3 parts of bismuth subcarbonate, and we were asked to calculate the quantity of each ingredient required to make 1,500 grams of the powder, we can get the sum or the total of the number of parts of each of these ingredients. So, 5 parts plus 1 part plus 4 parts plus 3 parts equal 13 parts of the mixture. Because we would like to prepare 1,500 grams of the powder, which is also our mixture, we can say that 1,500 grams of the mixture represent 13 parts of the mixture. We can perform either ratio and proportion or dimensional analysis to be able to get the amount of each of these ingredients. What we will do is simply dimensional analysis. For calcium carbonate, we know that it is present as 5 parts. Because the amount of the mixture is 13 parts, we just divide 5 by 13 and multiply this by the amount of the mixture that we want to prepare. Similarly, for magnesium oxide, we have 1 part divided by 13 parts times 1,500 grams. For sodium bicarbonate, 4 parts in every 13 parts of the mixture times 1,500 grams of the mixture. And for bismuth subcarbonate, 3 parts in every 13 parts of the mixture times 1,500 grams. So we will simply perform the operation, and what we get are the following amounts. For calcium carbonate, we get 577 grams. For magnesium oxide, we get 115 grams. For sodium bicarbonate, we get 462 grams. And for bismuth subcarbonate, we get 346 grams. Now, when you get the total of these ingredients, you should get the amount that is 1,500 grams. Checking, we got the correct answer. Now, in some occasions, you may also need to use a specific gravity to be able to determine the amount, either in weight or in volume, of the ingredient that is stated in the formula. So, let's consider this problem. The formula for a sports rub cream is given in the literature as follows: methyl salicylate 15 milliliters, menthol 10 grams, eucalyptus oil 1 gram, and hydrophilic ointment quantum sufficient add or enough quantity to make 100 grams. If the specific gravity of methyl salicylate is 1.18, how many grams of each ingredient would be needed to prepare a dozen 30-gram tubes of the ointment? Now, take note that the amount of the sports rub cream, as specified in the formulation, is 100 grams. Because when you see this symbol QS add, it means enough quantity to make. So each sports rub cream stated in this formulation would weigh 100 grams. Now we want to prepare a dozen of 30-gram tubes of the ointment. So that's 12 units or 12 tubes times 30 grams per unit or per tube, and this will be equal to 360 grams of the ointment. This is the total amount of the ointment that you would like to prepare in order to answer this problem. Let's use the factor method this time. Now, for the factor method, remember that the factor is equal to the quantity required over the quantity given. So the quantity required is 360 grams, and the quantity that is given is 100 grams. So we get a factor that is 3.6. Now, when the factor is greater than 1, it means that we are enlarging the formula. If the factor is less than 1, it means that we are reducing the formula. So what are we going to do with this factor? So basically, what we are going to do is we will use the factor to multiply to each of the amount that is stated in the formula. For methyl salicylate, in order to prepare 360 grams of the ointment, we would need 15 milliliters times 3.6, and that is equal to 54 milliliters. For menthol, we would need 10 grams times 3.6, which is the factor, and that is equal to 36 grams. And for eucalyptus oil, 1 gram times 3.6 will give us an answer that is equal to 3.6 grams of eucalyptus oil. All of these amounts are required to prepare a dozen 30-gram tube of the ointment. Now, take note that we are asked to determine the number of grams of each ingredient. Both menthol and eucalyptus oil are already in their gram units. So we will need to convert 54 milliliters of methyl salicylate to grams. And that is where the specific gravity of methyl salicylate will come into play. So remember that in converting volume to grams, we will simply multiply the volume by the specific gravity of the substance. And this will be equal to 63.72 gram, or approximately equal to 64 grams of methyl salicylate. Now, just like before, you can also perform ratio and proportion and dimensional analysis in this particular problem. But in this case, it is much easier to use the factor more than the other two methods. That ends my discussion on reducing and enlarging formulas.